Hello ladies and gentlemen. I noticed last week with the quiz that some of you were getting confused. You didn't know when to divide, you didn't know when to multiply, you didn't know when to move the decimal point to the right, when to move it to the left. So I decided to kind of take a back step and focus on equivalent ratios with all of these percent problems so that you just have one method to use so you don't get confused. So we're going to use equivalent ratios because you already know how to work with equivalent ratios from topic 5. And we're going to use this one strategy for all 3 types of percent problems that was shown in the Math Antics video. The percent proportion that you've seen me write on the board and you've seen in other videos is the part over the whole equals the percent over the 100. And percent is always over 100 because that's what percent means. It means out of 100 or compared to 100. And the part goes over the whole because it's that part out of that total. The part would be the numerator and the total is the denominator. Every question involving percent is either asking you to figure out what the percent is, find the part, or find the whole or the total. So if you can just remember this format, part over whole equals percent over 100, just remember that one thing, then you can use that for all the things and hopefully you'll get less confused. And to help you kind of picture what's happening here, so if we use this bar model and this whole thing represents 100%, it also represents the whole, and then whatever part they're referring to, whether it's, gingerbread cookies out of the whole jar of cookies, that would be, one piece of the whole bar model, and that would be, let's say if they said it was like 30% were gingerbread cookies, that would be that little percent there. So hopefully that helps you picture what's happening for some of these questions. So going back to the type 1 questions, when we were doing this on lesson 6.5 on Monday with IXL S10 and S11, you had to find 20% of 80. So in that sentence, find 20% of 80. 20% is the percent. The whole or total is 80 because that's what you're taking the percentage of. And the part is the thing that's unknown. So what we did last week was we just changed the percent to a decimal and we multiplied. So we changed 20% to 0.20 and we multiplied it by 80 and we got 16 as our answer. But I want to try to focus on just equivalent ratios so you don't have to remember all the different ways to do things. So since you know the 20 is the percent, that goes over the 100. And since 80 is the whole, that goes in the denominator. And then you're just looking for ways to get from 20 over 100 to whatever would be over 80. However we get from 100 down to 80, that's what you would also have to do to get from 20 down to whatever the part is. So it's not easy to get from 100 down to 80, but we can still use a calculator and say, okay, 100 divided by what will give me 80? And in order to do that, we can do 100 divided by 80. So if you do 100 divided by 80 in the calculator, that comes out to 1.25. So that means that 100 divided by 1.25 gives me 80, which means I can divide 20 by 1.25 to figure out what goes here. And if you do 20 divided by 1.25, you will get 16. Another way that you could do this, using kind of more mental math, is to scale this down to something where the denominator does work well to get into 80. So if we think about what could I divide 100 by, that would give me something that goes into 80. So let's try 20 because I know both of these numbers are divisible by 20. So divide both of these numbers by 20, that's going to give me 1 for the numerator and 5 for the denominator. And I know 5 goes into 80 because I know my divisibility rules says that anything that ends in a 5 or a 0 is divisible by 5. So since 80 ends in a 5, I know 80 is also divisible by 5. 5 times what equals 80? So if I do 80 divided by 5, that gives me 16. So I know that if I multiply this 5 by 16, it'll give me the 80. So whatever I do to the 5, I got to do to the 1 as well. So if I multiply that by 16, it gives me this 16 here. So you can kind of work your way down, scale it down to then scale it back up again to figure out what the number would be out of 80. So again, you can go straight there using a calculator, where we figured out that 100 divided by 1.25 was 80. So we can divide 20 by 1.25 to get 16, or you can use more mental math and scale it down first and then scale it back up. So we went from 20 over 100 down to 1 over 5, and then from 1 over 5 we were able to get to 16 out of 80. And the final answer for the part is 16 either way. That was a type 1 question. Type 2, which was also a part of lesson 6.5, was when you were finding the percent. And so the way we did this last week was we divided the part by the whole, 5 divided by 20, we got a decimal, and then we changed that decimal to a percent. Some of you were getting mixed up between this and what I just showed you in the last slide with when do I move the decimal point, where do I go right, do I go left, do I divide, do I multiply? And I get it. So I'm trying to streamline it again. Let's just focus on equivalent ratios. So 5 is what percent of 20? So you're saying 5 is the part, 20 is the whole, and we want to know what is the percent, right? So this one works out a lot nicer than the last question, because I know how to get from 20 to 100. I know that 20 times 5 is 100. So then I could just do 5 times 5, and that would give me 25 for this, okay? You could even look at it this way and say, whatever I do from 20 to get down to 5, I would do the same to 100 to get to this. And I know 20 divided by 4 is 5, so I could do 100 divided by 4, and that would give me 25 also that way. So the answer is 25% doing it that way. So that's a type 2 problem from last week. Here's another example of a type 2 problem from last week. 27 is what percent of 36? So last week we were dividing it. We were changing that decimal that we got to a percent. But now we're just going to focus on equivalent ratios. The part is 27, the whole is 36. And if you try using a calculator on this to figure out how to get from 36 to 100, when you do 100 divided by 36, it's going to give you a really ugly decimal. It's going to give you a repeating decimal. That's not going to help us. So we can't do that. When we try to figure out, okay, well, what about going this way from 36 to 27? If I divide 36 by 27, that also gives me a repeating decimal. So I can't do it that way either. But what we can do with this is using that scaling down to scale back up again. I know that both of these numbers are divisible by 9. And I know that when I divide by 9 here, 36 divided by 9 is 4, 27 divided by 9 is 3. I know I can get from 4 to 100 pretty easily. 4 times 25 is 100. So then I would just multiply this 3 by 25, and that would give me 75. So that still gives me the 75% answer that I was looking for. So again, you can try scaling down to scale back up again. So this is still a review of last week, 6.5, but using equivalent ratios instead. Just make sure you know how to set up the problem. You know that the percent was the thing that was missing. So that's what was blank, but everything else was filled in. Okay, here's the new stuff for this week, lesson 6.6. Now they will give you the percent and they'll give you the part, but you won't know what the whole is. It says 50% of something, of what number is 36. So the 50% is the 36, so that's why they're next to each other. The percent is 36, 50% is 36. And we don't know what we're taking 50% of, so that's why that's blank down here. We don't know what we're taking 50% of. We're saying 50% of what would be 36. So this is one that you could use equivalent ratios this way and say, okay, I know that 50 times 2 is 100, so I could do 36 times 2 to get me this answer here, 72. So I know that 50% of 72 is 36. So I could do it that way. Here's another one. 90% of what number is 81? 90 is the percent that goes over 100. Of what number, so we don't know what the whole is 81. So 90% is 81. That's why they're next to each other. They match up. But for this one, if you try to divide here to figure out 90 divided by what equals 81, you're going to get a repeating decimal, so we can't do it that way. And if you try also to figure out 90 times what gives you 100, that's going to give you a repeating decimal as well. So that's not going to work either. So we're going to have to try the scaling down to scale back up again. So I know that both of these end in a 0. So let's try dividing both of these by 10. I get 9 out of 10. I do know how to get from 9 to 81. 9 times 9 is 81. So then if I just multiply the 10 times 9, that gives me 90. So that means 90% of 90 is 81. Okay, so that's a type 3 question. And here's another type 3 question with bigger numbers. Don't be scared. And again, for this one, if I try to get from 60 to 100, it's going to be a repeating decimal, so that's not going to work. But what's nice is I can go from 60 to 36,000 pretty easily. I know that 6 times 6 is 36. So 60 times 6 would be 360. But this is 36,000, so that means I would have to multiply by 600. So 60 times 600 would give me 36,000. Okay, I have 1, 2, 3 zeros here to match up with these 3 zeros here. So if I'm multiplying by 600 to get from 60 to 36,000, I would have to multiply 100 by 600, and that would give me 60,000 for that answer. So 36,000 is 60% of 60,000. Once you get to envisions, this works even when the percent is greater than 100. That may seem kind of weird that you would have a percent greater than 100, but that just means you have more than one whole, right? So 210% of what number is 126? Which means 126 is more than twice whatever this whole is, because it's more than 200%. So for this one, there's no nice way, like if I do 210 divided by 126, going this way is going to be a repeating decimal, so we're not going to use that. But I could see how to get from 210 down to 100. That's a nice terminating decimal. That I can work with. If I divide 210 by 2.1, that gives me 100. So I can divide 126 also by 2.1, and that gives me 60. So my answer for this one is 60. 210% of 60 is 126. And then it even works when we have decimals in our problem. Don't be scared. It still works. 15.5%. I mean, trying to get from 15.5 to 100, again, doesn't really work out nicely. You get a really long decimal. But if you check this way, believe it or not, if I just do 68.2 divided by 15.5, it comes out to 4.4, which means that 15.5 times 4.4 would give me this number. So then I just have to multiply 100 by 4.4, and that'll give me the whole. So 15.5% of 440 is 68.2. And that's that. So use equivalent ratios for all of these. And sometimes you can go straight there. Sometimes you have to scale down to scale back up again, like we did on that one. Sometimes you can go from the numerator to the denominator. This was a scaling down to scale back up again. This one you could have gone either way. Like I said, you can go straight from, how to get from 20 to 100. You can go that, or you could have used this too. Going vertically, horizontally or vertically worked for that one. Okay, so just use the equivalent ratios for all of these so that you don't have to get confused. When do I move the decimal point? When do I times? When do I divide? All right, good luck on your assignments this week with lesson 6-6. This method will work for everything you're doing this week, including the quiz.